Here is a video that demonstrating how to prove Laplasian formula by the chain rule in the differential equations. Let's first start with investigating what is the partial derivative with respect to xi of f, because we can see that this is the second derivative of f with respect to xi, and sum them together. It is the Laplasian formula, and this is what we want to prove. First step is that we need to realize that fx is actually fr, as the question indicated. So we take the partial derivative to x. We have by chain rule, we first take it by the derivative of fr, and then we multiply by the partial derivative of xi. The r is partial derivative with respect to xi, because r is actually a function of x. It is actually equal to this, because this is the Euclidean distance of this vector, and we can see that this is actually f is actually an input of n dimensions and map it to one dimension. And by using this f, by using the relationship of fx equal to fr, we are actually designing an input space of Rn to R, which is this one, then to R. So this is why we see that this f is an R input to a real input to a real output. After knowing this, we start calculating this. We know that fx equal to fr. So take the derivative of this one, we get that. Note that this means we are taking the derivative of little f with respect to r. We treat it as a new variable, and then we, by chain rule, we use x to express r, which is we continue our calculations. We can have x1 take the derivative, we get this is also by chain rule. We simplify this expression. We get, I will just skip the n and I equal to 1 in the common content. So because they just eliminated, then we can see that this is actually R. So we now get this equation. we take the partial derivative of r with respect to xi, we get this. So back to the questions. We write the result as now, since the Laplasian is all second derivative, of the f with respect to I and add them together, we need to take the second derivative of f with respect to xi. This is equal to as stated above. So now we can see that by chain rule, we have two expressions that's related to xi multiplied together. So here we should use product rule. By using product rule, we get clarify that this is actually over here. This is and then we observe that here this is again an expression of xi and r. This is also a function of xi. Here, we will need to use the quotient rule. The quotient rule, not root. We know that by formula, we have because I divided the upper and the lower together by r. So over here, I actually made this happen. I move one of this r to the upper side. So we get this. And we summarize all this expression together. And don't forget that we actually have this on the outside. We get, and remember, this is only the big F, the second derivative with respect to arbitrary xi, and we still need to sum them together. Note that this is a linear operation, so we only need to apply it to the sign. That is it. But over here, you can see this is actually plus, this is minus, so we cannot just plug it over here. This is wrong. We have to consider that this one also being added for n times. So simplify this expression. We can now expand this. And we can see that it become we know this whole expression is equal to R. So we get and take it in. And we also know that this is also equal to and they cancel each other out. That's equal to 1. So this whole expression only left this. Take it down over here, which is what we are asked for. So this is the proof of Laplasian by chain rule. It's just like you extract the expressions layers by layers, and then you convert them back to a function of R.